Hi, this is Ms. Warnow, and welcome back to Chemical Reactions. Today we're going to talk about redox reactions, oxidation reduction reactions. Oxidation reduction reactions, the oxidation number of an element changes in a chemical reaction. So the oxidation number is the number assigned to an element based on the distribution of electrons. The same element can have very different properties in different oxidation states. So here are the rules, and you need to know these rules so you can assign oxidation numbers. So the oxidation number for any uncombined element is 0. The oxidation of an ion is the charge on the ion. So for example, chloride, Cl -1, the oxidation number is -1. And then just looking back up here, sodium is an element, 0 is its oxidation number. Oxygen, it's 0. Even though it's diatomic, it's an element, it's still 0. The oxidation number of elements and compounds typically, but not always, follow a trend. So group 1 tends to have a +1 charge. Group 2 tends to have a +2 charge. Group 13 tend to have a +3 charge here. Group 15 tends to have a -3, and group 16 tends to have a -2. Okay, and then group 17 tends to have a -1. Now fluorine's always -1. Okay, so if we look at here, lithium fluoride, if we just look at lithium, its oxidation number is +1. We look at calcium here, it falls in group 2, so it's going to be 2+. Fluorine here is 1-, and then hydrogen here, if we look at this, the oxidation of the overall compound is 0. Oxygen has a -2, so hydrogen here must have a +1. And it's a charge on a single element. The sum of oxidation numbers of all atoms in a neutral compound is 0. And you already know this from nomenclature, that all the charges for a compound add up to be 0. Now for an ion, particularly a polyatomic ion, it doesn't equal 0. It equals the charge on the ion. So when you have sulfate is 2-, the charge on that polyatomic ion is 2-. But if you're talking about the compound lithium fluoride, the overall chemical charge, or the overall charge on the chemical formula is 0. All right, so let's work this. It says determine the oxidation number for each atom in the following. So we have iron, and we have oxygen. So this is a compound, so overall it has 0 charge. The oxygen, has a 2- charge. So there's only one of them. So what must the charge on the iron be? There's only one, so it must be 2+. Okay, and if you add those up, here you'll see they add up to be 0. But what if they had subscripts? Let's look at them. The overall charge is 0. Oxygen is 2-. We can go ahead and do that, or -2. 3 times -2 is -6, so this must be +6, and there are 2 of them. So what's 6 divided by 2 is +3. Okay, so this is how we were doing our Roman numerals. We're actually finding their oxidation numbers. Carbonate, CO. Now, this is an ion. Its overall charge is -2, so it's not going to be equal to 0. So we know oxygen is 2-, so that's 2-. So this is -6. So what number plus -6 gives you -2? So the carbon must have a +4 charge, or 4+ charge. Lithium sulfate, we have lithium, we have sulfur, and we have oxygen. We know lithium is 1+. We can go ahead and do that. So that overall charge for lithium is +2. Oxygen we know is 2-. Yes. Or -2. I guess I'm going to try to do the 2-. Okay. So 4 times -2 is -8, and it's got to add up to 0. So what must sulfur be? Well, 2 and -8 is -6. So sulfur must have a +6 to balance out the oxygen and lithium. And then lithium here is sitting all by itself, so we know it's a single element, it's 0. Okay. Oxidation is a reaction in which there is a loss of electrons. So anytime something is lost electrons, we say it's oxidation. Now, when there is a loss of electrons, you're losing negative, so you're going to have an increase in charge, or the oxidation number is going to become more positive. Reduction reaction is one in which you have a gain of electrons. Okay, so you have chlorine, it becomes chloride, it's a -1 charge, it has gained electrons. Anytime you're gaining negatives, there's a decrease in charge, or it becomes more negative. Now, here are ways to remember this. Leo the lion says GER, Leo being losing electrons is oxidation. The lion says GER, gaining electrons is reduction. I always do oil rig, oxidation is loss, and reduction is gain, and of course, of electrons. Now, since oxidation is a loss of electrons and reduction is a gain of electrons, they must occur simultaneously. So if there's oxidation, you have reduction, and that's why I call it oxidation-reduction reactions, or redox for short. Any chemical process in which elements undergo changes in oxidation number is an oxidation-reduction. So you're going to actually be asked to say whether something's an oxidation reduction. So let's assign numbers to each one of these. You have iron and you have oxygen. So the oxidation number of iron is 0 on the reactant side, and for oxygen it's 0. Why? Because they're single elements sitting by themselves. On the product side, you know, oxygen is 2 minus. So that's -6. So this is +6. So the iron, 6 divided by 2, is 3 plus. Now, if oxygen, or let's just focus on iron. If iron has become positive, it was originally neutral and now it has a positive, did it lose or gain electrons? It had to have lost electrons. It loses. And so is that oxidized or reduced? Well, that's going to be oxidized because oxidation is loss. Oil rig. Oxidation is loss. You get 2 minus, so oxygen must have gained. And so is that oxidation or reduction? That is reduction, because reduction is gaining electrons. Now, what type of reaction is this? Well, this is a synthesis reaction, okay? But it's also considered an oxidation reduction, or redox, because there is a change in charge from this side to this side. Okay, here's another way we're going to another practice. So we look at magnesium. We know this is 0 on this side. Okay, what is it going to be on this side? It's in group 2, so we know it's going to be 2 plus. Okay, so did it gain or lose? It had to have lost, right? Okay, so was it oxidized or reduced? Okay, oil rig. Okay, oxidation is the loss. Then we look at hydrogen. Hydrogen right here is a 1 plus charge. On this side, it's by itself, so it's a 0. So if it goes from a positive to 0, it had to have gained electrons. And when you gain electrons, okay, you're going to be reduced. Reduction is the gaining of electrons, so you get reduction here. And then let's look at the chloride. It's -1 on that side. It's still -1 on that side. It did neither. It wasn't oxidized or reduced. It was the magnesium and the hydrogen that were trading electrons, or one was gaining and one was losing. Okay. Here's another example on redox. So let's write down our elements: hydrogen, chlorine, sodium, and oxygen. Right? We know that hydrogen is going to have a 1 plus charge on this side, and it also has 1 on this side. Look at chlorine, it always has a 1 minus, and it still has a 1 minus on this side as well. Sodium is in group 1, so it would have a +1 charge, and on this side it still has a 1 plus charge. And look at oxygen, has a -2 here, 2, and over here it still has a 2 minus. We do have another hydrogen here. We have hydrogen in 2 places, so we should just make sure what this particular hydrogen's charge is. So hydroxide is OH 1 minus. We know oxygen has a -2, so this hydrogen must have a +1, and so that's okay. This is good. And so when we look over here, there's no loss of electrons here, or gain, none here. None here, none here, none here. So this would be not redox. Okay. This concludes video 5 on reactions. You should have taken high quality and in-depth notes. Rewatch the videos as needed and ask questions in class.